Guys, so today we're going to go over the volume of a square box when given the side. Um, so I want you to keep in mind that even if they haven't given you the formula, remember you were in geometry, the volume of a square box is just the side to the third power. So meaning side times side times side. So in this case, side to the third power just means side times side times side. So this is 2 over 5x plus 3 times 2 over 5x plus 3 times 2 over 5x plus 3. Now, yes, you can FOIL and distribute. That is always an option you have. However, if you are just expanding the same binomial, meaning the same 2 over 5x plus 3 to the third power or to the fifth power or to the seventh power, you can always use Pascal's triangle as well, which I did upload a separate video on that one. Pascal's triangle starts out with 1. Every row begins with 1, ends with 1. Every row begins with 1, 1 plus 1 is 2. Every row ends with 1. Every row begins with 1, 1 plus 2 is 3, 2 plus 1 is 3. Every row ends with 1. I'm stopping here because the second number in each row will tell you which power you're working with. So I'm going to work with these numbers 1, 3, 3, 1 since it's s to the third power. So remember, please go over the Pascal's triangle tutorial if you haven't already done so, since I'm kind of just skipping past the basics on it. So 1331 tells us the coefficients for each term. And what happens is I always take the first term I'm working with and give it the same power as the power I'm working with as well, which is 3, and then it counts down. So for the next term, it's 2 over 5x to the second power. And then after that, it's going to be 2 over 5x to the first power. And then you can write 2 over 5x to the 0 power if you want, but anything to the 0 power is just 1, so I choose not to write that. And then what happens with the next term, that plus 3, is it goes the opposite way. So it starts off with the 0 power, which again I don't write, and then it gradually increases. 3 to the first power, 3 to the second power, and finally 3 to the third power. So you're working with each term, keeping in mind PEMDAS. So meaning 2 over 5x to the third power. Well, when I have a fraction that has a power, each numerator and denominator gets its own power of 3. So 2 to the power of 3 is 8. 5 to the power of 3 is 125. And x to the power of 3 is x to the third power. Times 1, nothing changes. But for the second term, I have 2 over 5x squared. So I'm going to square each one, giving me 4 over 25x squared. And I'm multiplying it. Notice that this first number is 3 over 1. And 3 to the first power is also 3. Fraction form is 3 over 1. I'm saying 3 over 1 because to multiply fractions, you just go straight across, meaning you multiply the numerator with the numerator and the denominator with the denominator. So when I multiply straight across, this becomes 3 times 4 times 3 gives me 36. 25 times 1 gives me 25. And bring down the x squared. It's positive. That 8 over 25 or 125 x to the third power, that was being multiplied to 1. Nothing happens to that, so I'm just going to bring that down. And then 2 over 5 x to the first power. Well, if I raise it to the first power, nothing happens, so I'm going to bring that down. 3 to the second power gives me 9, which the fraction form of 9 is 9 over 1. And again, that first number of 3, fraction form is 3 over 1. So within this term, the third term, I have everything I need just to multiply straight across. 3 times 2 times 9 would give me 54. 5 times 1 would give me 5, bring down the x. And then finally, plus 3 to the third power, again, exponents come before multiplication. So remember PEMDAS. 3 to the third power is 27, and then it's just being multiplied to 1. So 27 times 1 would just give me 27. And that would be the volume. All right, guys, hope this helps.